Okay, this worksheet does making a decision. So it's only what you do if you, what you're going to do. Do you reject or fail to reject HO? That's it. That's all you're trying to decide. So this will either compare P to alpha or your test statistic to the critical value. So for this one, you might need to find some of those T critical values, like I mentioned on the notes. So find the p-value associated with z equals 1.65. Assume a right-tailed test. So if we assume in a right-tailed test and z is 1.65, then our p-value is the area up here. So our p-value is equal to, if it's the right, we have to subtract whatever's on the chart from 1. So we would have 1 minus, for 1.65, 1.6 over to 0.05 is 0.9505. 0.9505. 0.9505. So if you subtract that from, or 1 minus 0.9505, I didn't have it wrote down here. It's 0.0495. So that's our p-value, that's this. And it says if alpha is 0.05, what is the decision? So if I compare P to alpha, .0495 is less than 0.05, so P is low, I reject HO. Find the p-value associated with z equal to plus or minus 1.32 and assume a two-tailed test. So for this p-value, if we assume a two-tailed test, the p-value is the area in both tails. So if we look at negative 1.32, negative, let me get the right chart out here, negative 1.32, we've got 0.0934. So we have this side is 0.0934, and this side would also be 0.0934 because it's symmetric. So our p-value is, if we combine those, multiply by 2 or add them together, it should be 0.1868. Is our p-value. If alpha is 0.10, what's your decision? So compare P to alpha. 0.1868 is actually greater than 0.10, so we would fail to reject. P is bigger than alpha. So fail to reject HO. If we want to find the critical value of a left-tailed test, if alpha is 0.05, assuming a normal distribution, so it's a Z, not a T, and then it gives us a test statistic to test. So for a left-tailed test, and alpha is 0.05, that's the area in the left tail. And remember, this shaded part is your rejection region. So to find your critical value, you do the inverse norm of 0.05, since it's in the left. You'll get negative 1.64. It says if the test statistic is negative 1.78, what is your decision? Negative 1.78 is over here. Not that far away, but just so I can write it, I scooted it over. So it's inside that shaded region, which is the rejection region. So we would reject HO. If you want to find the critical value of a two-tailed test, and alpha is 0.08. So this is the area in both tails, which means if 0.08 is in both tails, that means half's in the left and half's in the right. So 0.08 divided by 2 is 0.04. If we do the inverse norm of 0.04, you should get negative 1.75. And then it's symmetric, so that one's positive 1.75. So that's your critical values, plus or minus 1.75. If the standardized test statistic is 1.71, which is there, what is your decision? It is outside that shaded region, your rejection region, so we would fail to reject. If it's outside the shaded region, you fail to reject HO. And then for the next page, this one has the T ones where you find in the T critical values. So this is where you're going to do the degrees of freedom. So find the critical value of a right-tailed test. If alpha is 0.05, so that would be, if it's a right-tailed test, that's the area in the right tail being one tail. With a sample size of 32, it has to tell you the sample size because your degrees of freedom is going to be n minus 1, 32 minus 1, which is 31. So what we're going to do is we're going to go to our chart over here. I've still got it open. Our alpha is in one tail, 0.05 in one tail. You're going to look in the first column. Scroll down, your degrees of freedom is 31. So I'm at 1.6955. For Z's, we always round to 2. For T charts, they give you 4 decimals, so you can use 4. You can round it however you want to do it. This one, you do not make negative because it is in the right, so it is positive, so that's fine. What is the if the standardized test statistics 1.52, what is your decision? 1.52 is over here to the left. It's outside that rejection region, so we would fail to reject HO. Critical value of a left-tailed test if alpha is 0.01, T distribution with a sample size of 46. So if it's a left tail, that's the area in the left tail, which again is one tail. Tail. So alpha is 0.01 over here. Your sample size is 46, so that means for this one, our degrees of freedom is 46 minus 1, which is 45. So I'm going to look at, on the chart, I'll just scroll back up for just a second. Alpha is 0.01 in one tail, it's the third column here, and I'm going to scroll down to 45 for my degrees of freedom. So what did I say? Third column, 1, 2, 3. 2.4, yeah, 2.4121. But you have to remember, for this, our alpha is in the left. It's a left-tailed test, so we have to make it negative. If T is negative 1.94, what do you do? Negative 1.94 is to the right of the negative 2.4121, so it's outside that shaded rejection region. So again, I would fail to reject HO. Critical value of a two-tailed test if alpha is 0.05, so this is the area in both tails. So two tails. T-distribution, sample size of 20. So if alpha is 0.05, then divide that by 2. This is 0.025, and that's 0.025. Not that that matters too much, because on the chart, for T-chart, if you look here, we have 2 tails for 0.05, or it says 1 tail for 0.025, which makes sense because alpha is 0.05 in both. That means it's in 0.025 in each, so that's why that column's the same. And then for this problem, our degrees of freedom, I didn't write it down yet. Sample size is 20, so 20 minus 1 is 19. So scroll down. So we're going to look here at 0.05 for 2 tails, or 0.025 for 1 tail. So the second column, and we're going to scroll down to 19, somewhere here. We are at 2.0930. But you have to remember, if it's that one, this one down here has to be negative, and this one up here would then have to be the positive one. So plus or minus 2.0930 is your critical value. What's your decision if T is 1.97? 1.97 is here. Again, it's outside that shaded rejection region, so again, you would fail to reject HO. The last one here, find the critical value of a left-tailed test if alpha is 0.05, so that's the area in the left tail. It's 1 tail. T-distribution with the sample size of 64. So there's alphas in the left tail, 0.05. Sample size of 64. Means our degrees of freedom is 63. So I'm going to look at 1 tail for 0.05, which is the first column, and I'm going to scroll down to 63. Now, most charts don't give you 63. This one gives you a whole bunch. Most charts would actually, when you get down to like 50, they go 50, and then either count by 10s or count by 5s. I'm not sure. So if you had another chart and it didn't have 63 on it, you would just use 60. Because most of them do have 60 on it. So you just go to the closest one that you have on your chart. This chart happens to go up to 200. So we'll use this value. It's 1.6694. But again, you have to remember we're talking about the left side, so we have to make it negative. So our critical value is negative 1.6694. And what's your decision if T is negative 2.14? That is inside that rejection region, that shaded region. So we would reject HO. So this is finding the T critical values and making a decision if you wanted to, when you do T-test, if you want to find T critical values and then use the T that it gives you to decide, that's fine. But most people are just going to do P to alpha. But this way you can see these problems, how you decide, because I talked about it in the notes. I didn't talk about it, I try not to talk about it in huge great detail, but enough to where if you were going to do it that way, you kind of halfway know, or if you see it done that way, you kind of halfway know where it comes from. So this should help you with homework. This was only about making a decision whether you rejected or failed to reject your HO. And then if you have any questions, please let me know.